You already know that some chemical reactions release energy and some absorb energy. Here are two examples. The first chemical reaction releases energy. It's pentane reacting with oxygen and forming carbon dioxide and water. The reaction below absorbs energy when it occurs. Potassium nitrate, the solid salt form, when it dissolves in water, forms potassium ions and nitrate ions. That reaction absorbs energy. What you observe for a chemical reaction that releases energy is that the reaction gets hot and thermal energy comes out. What you observe for a chemical reaction that absorbs energy is that the reaction feels cold to the touch. So how do we describe the flow of energy or the flow of heat? We have to break the universe into two components. First is the system. That's the substance being studied. That's typically the chemical reaction. The other half is the surroundings. That's everything else, the rest of the universe. And practically speaking, that's the immediate rest of the universe, things in the immediate vicinity. Let's talk about the relationship between the system, the surroundings, and how energy is transferred between them. In this class, we're going to talk about the transfer of heat energy between the system and the surroundings. The symbol for heat is Q. If the system is releasing thermal energy, releasing heat into the surroundings, we say that has a negative sign for Q, because heat is being released to the surroundings. That is a energy out and exothermic reaction. Conversely, if the system is absorbing energy from the surroundings, the sign of Q is positive. That means that heat is flowing from the surroundings into the system. We call that an endothermic reaction. Let's revisit the two reactions we talked about at the beginning and think of them in the context of being exothermic, as in thermal energy being released, or endothermic, as in thermal energy being absorbed. For the first reaction, the system is the chemical reaction that's occurring. So that's the propane being burned. The surroundings, when you burn propane, are most often things like a burger. That would be the thing absorbing the energy. So we can see from this cartoon that the system is releasing thermal energy to the surroundings so that you can cook the burger. The reaction below, the system is the potassium nitrate ions, or potassium nitrate solid, dissociating into ions. The surroundings would be the water, the beaker, your hand, the air, the immediate surroundings. So when you do this actual experiment, you feel the beaker become cold because thermal energy is leaving your hand and entering the system. It's being absorbed by the chemical reaction.